Yeah, so can anybody say that what are these options, or there is any similarity between these options? Like what are these? I hope you all of you have completed your first week of this course, so you might be knowing, or you just guess it, like what do you think, what are these kind of features or manifestations, I would say. So no problem. So these are the landforms that generally form due to the plate movement or due to the plate tectonics. So to understand this question or to answer this question, first we need to understand what are these plate and how this plate moves, and then I think you all of you can answer this question with lots of confidence. So let me start. I'm facing problem here. Okay. So first, that we all know that Earth mainly consists of three primary layers, that is core, mantle, and crust. Okay. So here we'll be majorly focused on the crust part. Now the question comes, why crust part? Since the plate is consist of crust and the upper part of mantle, so that's why first we'll discuss what are these crust, and then we'll go that what portion of mantle also include into the plate part. So that this in this figure you all can see that here this thick body is called as the continental crust. Okay, and this the which is not that much thick as compared to the continental crust, we called it as a oceanic crust. And if we talk about the thickness, so the thickness of oceanic crust varies from 10 to 70 kilometers, on contrary to oceanic crust, which is very thin and has a thickness around 7 kilometers. Now the another difference between these two crusts is that about the density. So the oceanic crust is less dense as compared to the continental crust. Now anybody can say that why there is a difference in between the density, or what is the major player behind this contrast? Any suggestion? What do you think, like why this density contrast is coming in both the crust? So I hope you all are there, right? Hello. uh, अरे आ क्यों नहीं रहा है? तो चेकलिस्ट क्या, इंटरनेट चला गया, इसकी क्या चेकलिस्ट बनाऊँ? Hello, sorry. Sorry, I got the internet connection. Okay. Uh, Hi, Raghav. So, I think now we got it. So, I think I should start from where I've left. So, I'm again sharing my screen. So, I hope it is visible to all of you. Is it? Okay. So we were discussing about the crust. So as I mentioned that we have mainly continental crust and the oceanic crust. And I was asking that why there is a density difference between the oceanic crust and the continental crust. So anyone can suggest like any guess why it is so? Yes, correct. So yes, it is because of the composition. Because in continental crust we mainly have the granitic rock, and for the oceanic crust we mainly have the mafic composition. So now as we discussed about the crust, so we got the idea that we have a two major crust, continental and the oceanic crust. Now moving ahead, what other else is comprised under the uh, plates? So, okay, sorry, there's some issue related to touch. Okay. So after that, we have another concept called lithosphere. So what this lithosphere suggests is that so the lithosphere forms the plates, and it is the rigid surface or shell that includes the crust and the upper mantle part. As you also can see in this section of the earth's subsurface, so it comprises of the crust and up to the upper mantle part, which forms the rigid plate, and that plays a major role in the plate tectonics. And below that lithosphere we have a asthenosphere, because to move that plate easily we need to have some liquid material on which the plates can float. So in that scenario asthenosphere act as a motivator for plates to move. Now, having idea about the plates, so on that basis we have a two major plates. First is the oceanic plates and the continental plates. And as per these, now we have a plate movement. So I hope you all are familiar with this concept. So just give you a brief that this is the again a cross section of the Earth's internal structure, where the solid part that we have just now discussed is the lithosphere. Okay, and below that that mantle convection will help the plate motion to happen, and due to this plate motion we have a different type of boundary, and through that boundaries we got the different kind of landforms. For example, here you can see that one plate is subducting under the other plate, so there is a high chance that the trench will form. Another example, when the two plates are diverging, on that scenario we'll get the ridge kind of land features. So let's understand these plate movement in bit more detail. So here we have a major three style of plate movement. First is the divergent. So from this figure you can understand. So this is the plate boundary between these two plates. So for example, this is the plate 1 and this is the plate 2. Now the motion of these two plates is away from each other, so that's why we are saying that this is a divergent kind of movement. Another kind of movement is the convergent movement, where these two plates, so this is the plate boundary, and this plate is moving towards, these two plates moving towards each other. So since they are moving in the direction to each other, so that's why we are calling it as a convergent plate movement. Another third category of these movement is the transform movement. So where these two movements just strike slip along the boundary. Now, so to answer the question that I have discussed earlier, we'll be focused mainly on the convergent boundaries. Okay. So under the convergent boundary, there could be a three kind of scenario. So as we discussed that we have a mainly two type of plates. First is the continental and the oceanic. So if you'll find the combination, so there could be a three major combination, like continental collision would be one, and then the continental and ocean collision will be the another kind of movement, and the third one would be the oceanic collision. So let's understand all these three collisions one by one and what kind of landforms they could lead to. So moving forward, so this is the example of continental collision. So where you can see that this is we marked as plate 1 for understanding, and this could be our plate 2. So you can see that plate 1 is subducting under the plate 2, and due to that subduction there are lots of mountain range are forming on the boundary. Now the question comes that how we'll decide that which plate subduct under which plate. So can anybody tell, like how we can decide that which plate will subduct under other? Yeah, correct. So the denser one plate will go under the subduction. So the example of these mountain kind of landforms include Alps mountain range or Himalayas mountain range that we see. Now another kind of collisions is continental oceanic collision. So now where the oceanic crust, which is the more denser that we have discussed, will go under the subduction, and the continental crust will be on the upper side. And due to this kind of subduction, we generally see the volcanoes. Wait, I think. Okay, let's continue. So in this continental oceanic collision, so we generally form the volcanic arc, and the example of this volcanic arc are Andes range or the Mount St. Helens. Now moving forward, the third category that we have is the oceanic collision. Now since both plates are of same nature, so again the plate which has the denser material will subduct under the less denser plate, and due to this kind of plate motion we generally see the trench kind of landforms. And we all know the famous example of the deepest trench that we have on the earth globe is the Mariana Trench, which has a depth of 11 kilometers. So I hope till now everything is clear to all of you. So if we'll again go back to the question that we were trying to answer through these concepts, so which was I think this one. So now I think you all can suggest what would be the answer of this question. Now we have a two plates like Nazca plate and the South American plate. Now the question comes like what type of plate these are. So can anybody tell what Nazca plate is? Is it oceanic plate or the continental plate? I hope you all are there, right? Okay, so the answer of this question is that we'll have the Alps mountain range, because they both are the continental plates, so due to which Alps mountain will form. Now moving ahead to the second type of question that I have taken to answer is that around 60 million year ago, Indian plate started its and there's a fill in the blanks journey and collide with the Eurasian plate, resulted into the formation of Himalaya. So these are the options, available option that we have. So So to answer this question, let's see how the Indian plate has started its journey before the collision. So this is the figure. I think you all can see. So it started around 71 million years ago, and then it moved towards this direction. And if we consider that our north is like this, so what do you think that which direction it is moving towards? So if we'll see the whole direction map, so it is our north, it is our east, west, and this is the south. So what do you think that which direction this Indian plate is moving? Northeast, correct. So this is the northeast direction in which the Indian plate moved before colliding with the Eurasian plate. Now moving to the third problem that I have taken to explain you is this. So now it's related to the earthquake. So suppose an area is affected by the earthquake of moment magnitude 8. What would be the possible surface rupture occur in that region? So to answer this question, I think this is the figure that I have taken from the sir slides that sir discussed during this lecture. So if we'll go by this figure, so now in question it was giving that earthquake moment magnitude was around 8. So now what would be the surface rupture? So to address this with this figure, I think it's bit easier, because we can see that around 300 kilometers surface rupture we can observe when we have a moment magnitude ranging from 8 to 9. So this is the very approximate to answer approximate way of answering this question. But in general, like, because here we have a very limited information provided, because we given only the moment magnitude. But what if there are lots of information giving and you want to precisely calculate that what would be the surface rupture? So to deal with this kind of questions, first we need to understand a few empirical relations. So here this mw is the moment magnitude, and the another variable or another quantity that this relation has, it's m naught. And what is m naught? M naught is the seismic moment. So can anybody know what is the seismic moment or what is the moment magnitude? Okay, no problem, we'll discuss, we'll learn over here. So first let's see what kind of relations we have. So this is first relation between the moment magnitude and surface moment, and this relation is in SI unit. So since we know that moment magnitude has no unit, but seismic moment has, so if you use this relation, then m naught will be in the dimension of Newton meter. Okay, and another relation that we have, that is in the CGS unit. So if you use the second relation, you will have the m naught in the unit of dyne centimeter. Now, having idea about these two relations, let's first now understand what is m naught or seismic moment. So here is a very simple formula of seismic moment, which states that it equals to the static friction coefficient, that is mu, and here S is the rupture surface area, which is in the meter square, and D is the displacement, which is in the meter unit. Okay. So if you solve this relation, you can also calculate the unit of m naught, because the rigidity or the friction coefficient is in Newton per meter square, and our area is meter square and displacement is in meter. So if we solve, then m naught will be in Newton meter. So this is how we'll calculate the unit of m naught. Now let's move to the concept related to m naught, like what is m naught or what is the earthquake magnitude. So there are two parameters that we generally consider, is the intensity and the magnitude. So intensity is more like a non-scientific way to quantify the size of the earth, because it's related with the fidelity that happened due to the earthquake. But there's a experimental way to determine the size of earthquake, is the earthquake magnitude, and there are several ways to calculate the magnitude, but the most widely used is the moment magnitude that we have discussed just now. So to calculate the moment magnitude, we need to first calculate the seismic moment here. So as it says that the area S of the fractured segment and the amount by which it slipped, that is D, that is the fault displacement, can infer, and together with the rigidity modulus, that is the static friction coefficient, it can quantify the seismic moment m naught of the earthquake. So this is the formula that we have seen earlier. Now moving to that, so this is the illustration through which you can understand that how these parameters are coming. So this is the hole which I am highlighting, is the ruptured surface area, whose length is L, that is over here, and whose width is W, like this. And D is the slip that occur along the fault. So here you can see that this is the displacement that happened after the earthquake has occurred. So now first we need to calculate the m naught, and then we can calculate the moment magnitude. But the problem that was provided us, where mw is already given. So we need to calculate m naught, because we want to calculate the D or the displacement that has occurred. It's not the displacement, we need to calculate the length. So we can break the area into W into L, and then we need to calculate the L, that is the surface rupture length. Okay. So to do that, I have taken one problem through which we can understand that how we calculate these parameters. So let me start here. Okay. So the relation that we were seeing was like m naught was equal to 2/3 log 10 of m naught minus 9.1. I am using the SI form of this relationship. Now what we were given, that it was giving that moment is 8. So here I have added some extra information to calculate the precisely that what would be this rupture length. Okay. We have moment 8, so I am just putting the values that we have. Now it's 2 by 3 log 10 m naught minus 1.1. M naught minus 9.1, and if we'll solve this, what we'll have, 12 plus 9.1, that will give us 21.1 equals to log 10 m naught. Okay, and if we'll solve all this expression, take the anti-log, and I'm taking just approximation to make the calculation simpler. So our m naught will come around 10 to the power 21. Okay, now what we need to do, since we need to calculate the length, so we'll put this m naught into the another relation that we were using, which was like m naught equals to mu, and I'm breaking the area into length by width, and then we have the displacement, that is the fault displacement that happened along the fault. Now let's put the values that are available to us. So m naught is 10 to the power 21 that we have just now calculated. Now we know the static friction coefficient, which is equal to 3 into 10 to the power 10. Now this length we need to calculate, so I'm keeping this like this only, L, and W, that is width of that rupture area, we know that is 13 kilometer, but since we are dealing in the SI unit, so we will convert these 13 kilometers into meters, so it would be like this, 10 to the power 3, and we have a D is 8 meters. And if we'll solve for L, so what it like to be 10 to the power 21 divided by 3 into 10 to the power 10 into 13 into 10 to the power 3, and I think I've missed another quantity, that is 8. And if we'll solve this value, so I've already solved it, it would come like this, 0 0 3 2 0 5 and so on, there are the other terms, into 10 to the power 8, and that is in meter. So if we convert it into kilometers, so our L would be equal to 320.51 kilometer. So this is how that figure that you have seen, so it is just an approximation of all these calculation that we have done just now. So this is the indirect way, or this is how this figure is based on. So in future, if you face any kind of these questions, then you can solve using this method. Like first you need to calculate the m naught, and then through m naught you can easily calculate the whatever parameter that you need to calculate. For example, in some question they can ask you to calculate the rupture surface area or just a displacement. So I think now you all can solve this kind of problems. So I think this is for this week 1 question, the problem that I have taken. So if anybody has any questions, they can ask or related to this session, particular session, if you have anything to ask, please go ahead. Or at any point you feel that you didn't understand that step, so please feel free to ask. So no question, like you all have understood everything, right? I hope you will able to, yeah. Hello. I think somebody was saying something. So first, okay. You mean question 3, right? Okay, yeah. So answer of previous question, yeah. Sorry, I forgot this. So what do you think now after seeing this? So what would be the answer? The magnitude given was 8, and since the other information is not given, so we can't precisely calculate what would be the exact surface rupture length. So what do you think that what could be the answer if you see this figure? So what do you think? So from this figure we can see that we are, sorry, kilonewton. How kilonewton? I think I should read the question again. So what it is asking, that let's first understand. Okay, the question says, suppose an area is affected by the earthquake of moment magnitude 8.0. Okay, now what would be the possible surface rupture that occur in that region? Okay, now let's visualize this scenario first to come up with the answer. So to visualize the scenario, so this is the how, suppose if earthquake occurs, so these kind of changes we can see in the surface. So this whole region which I have marked with a blue color that I am shading is showing the rupture area. So there are mainly two kind of deformation happens. First is the surface rupture, and second is the displacement along the fault. So this is the you can understand that this is the surface. Okay, and here it's the below surface. This blue region that I have highlighted is below the surface, and this fault manifestation that you can see is on the surface, and there is offset between these block and this block of D. That happened due to the like displacement along the fault, because this is how earthquake propagates. So first their displacement happen along the fault, through which energy gets released, and through that energy, since the energy is so much high, so this area, the area that is adjacent to the fault got ruptured, and this ruptured area we are talking about. Okay, so since this is the area, so it has a length and it has a width, and another parameter that I have mentioned, that is a D, that is the displacement along the fault. Hope till now everything is clear to all of you. Is it? Please respond. So yeah, it will also help me to, if it is not, then I'll change the way of explanation. So please keep engaging, and if you don't understand, then don't feel hesitated, because this is why I am here to answer your queries or to solve your problems related to this course. Uh, okay, so since now we have this information, we can calculate the m naught, that is the seismic moment, correct? Now we know the displacement along the fault, we know the surface area that got ruptured, and the another parameter that we also need to have is the rigidity, because here we are talking about uh, I hope you know that when the fault ruptured, since there is a friction coefficient, so once this earthquake energy surpass that friction coefficient, then only there would be a movement along the fault. So that's why we have considered this rigidity factor also into this calculation. Now you may ask that why we are calculating this moment magnitude, because there are another parameter also, like by calculating the amplitude of seismic waves that got released at the time of earthquake also, so that we also can calculate that there are another method to calculate the magnitude. First is the MB and another is the MS. So in MB we measure the amplitude of think I should change the color. So for MB what we calculate the magnitude or amplitude. Okay, we calculate the amplitude of body waves, and that's how this B come into the picture, and another is MS, that is for the surface wave. So there are two methods through which we can also calculate the earthquake magnitude, but since these two methods are not very much reliable, so that's why we calculate the moment magnitude, which is considered the more scientifically accepted form to quantify the size of the earthquake. Now why it is widely used or scientifically valid magnitude? Because here we are considering the actual disruption that has happened due to the earthquake. Rather than calculating the wave's amplitude, we are actually calculating what has happened due to that earthquake. So if the magnitude would be large, then this rupture area extent would be also large. So even in this figure you can also see the same kind of relation. So since as the magnitude is increasing, you can see that this surface rupture length here, it shows that surface rupture length which is in kilometers. So this surface rupture length is also increasing. So when we talk about the moment magnitude of 9, you can imagine that how long this surface rupture is. It's around 1000 kilometers. So like how much damage it has happened. And that is the one of the greatest earthquake that occurred in Chile in 2004, where you can see that sir has also written that it got the surface rupture of 1300 kilometers. So you can imagine that how massive destruction must have happened due to this kind of great earthquakes. So that's why we consider moment magnitude, it's more acceptable form of the earthquake size. Now any question related to this figure, or related to seismic magnitude or moment magnitude, or why we are calculating it and how we can calculate it, any parameter that they could have asked you in exams or in further assignments. So I hope now you all can solve and even understand that why we are doing this. It's clear to everyone, right? Anybody else has any question? Okay. And related to the plate tectonics part also, you all have understood? you have like read about all these concepts earlier as well, right? Okay, and related to this earthquake part, is it new to you, or this part also you have already covered? Yeah, yeah, in the course, or even in your BSc also. So have you all covered this earthquake course earlier, or this time you are reading it, like in course? Okay, okay. So this thing I think you all have understood, and if this like similar kind of problem will be giving to you, so you will be able to solve it, right? Okay. See, you must be wondering that why I'm repetitively asking, because I just, since it's our first session, so I just want to make you comfortable, and also want to make sure that you are understanding what I am trying to explain. So that's why I'm repetitively asking. So I'm glad that you have understood all the concepts that I have discussed during this lecture. So first, let me stop sharing. Okay, I think we are done. So if anything else you want to discuss, please go ahead, and if not, then we can close this session. So in the next session, just to give you a brief, we'll be solving the session flow will be like this only. Like I'll take 3 to 4 problems. So, so the flow will be like this only, that I'll take 3 to 4 representative problems uh, during this session, and we'll also discuss the related concepts to solve that questions, and even the similar questions also. So I think, yeah, I'm done from my end. So if you all don't have any other questions, then we can close this session, and hope to see you in the next week, where we'll discuss about the week 2 assignments related problems, and will help you to solve that week 2 assignments. So yeah, 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 sure. Mm-hmm. Okay. Mm. Yeah, correct. No, actually, I'm also not, but definitely I also think the same, that this would not be possible, that they'll like, since it's online, so it's not possible. But that question you can post on the discussion forum, so where you can get the answer. So I don't have any information regarding this, but yeah, if you'll post this question on the discussion forum, then definitely you'll get the answer from the uh, team, like teaching assistant people. They'll help you to answer this question. But I think that what feeling I'm getting, that they'll show you the field photographs, or like how from the field survey you can identify the subsurface rupture or subsurface deformation due to earthquake. So I think it would be more like this. But yeah, definitely you can check with them. They'll be the right person to answer this question. But yeah, and one more thing I would add, that if you have, like, during the course, if you feel that you want to understand some specific concept, then I think you can tell, then I can prepare my next lecture in the same in line your in which area you want more explanation. So if you have any concern, that you can share with me right now. So maybe in the next lecture I will include that particular topic, and will I hope I'll help you to understand that. Maybe not today, maybe in the next week, if you feel like, then please you can inform me, and then I can even I can pick the problem to that particular topic on which you are stucking. So yeah, this we can do. Yeah, okay. So thank you, all of you, and I wish you a good evening, and yeah, meet you in the next Tuesday at the same time, from the 6 p.m. to 7. Okay, thank you all, and have a good day. Bye.